Thank you for having me, and thank you for the introduction. So you already know my name. I am, exactly, at the Max Planck Institute for the History of Science, as well as the Bifold or Berlin Institute for the Foundation of Learning and Data. And I'm also a guest lecturer at the Technical University of Berlin, where usually I teach about digital humanities. And you already know my background is very multidisciplinary and heterogeneous, if you want to say. So today I will talk about how to deal with heterogeneous data and how to explore it. What's some of the approaches that are applied, that have been applied in some of the projects that I participated in. And how we can actually change the narrative just on the use of AI. So instead of just using AI for data exploration, like image analysis or extraction, but how to make AI as a partner. So we kind of close the loop. So like we get some information and we give back the information to the domain experts. Okay, sorry, is this better?
Yes.
Okay.
Better, yeah.
Okay, cool. We can start. These are the main things I will talk about. So I will focus on a collection of books. So this is part of a project that will be kind of a theme throughout this whole presentation. And this collection of project, along with its metadata, along with a lot of added value from historians who worked on this collection, are stored in a knowledge graph. So you can see my cursor, right? So the knowledge graph here is just a very abstract representation. And from this knowledge graph, we try to derive data and we try to explore the knowledge graph on a meta level. So instead of looking at every single book or every single element, first of all, because we don't have the resources, sometimes the life cycle of the research is very short. So we want to see what can we find, like some interesting aspects of the knowledge graph, and then the data, obviously. And then the second part of the presentation, I will focus on historical insight generation using explainable AI. Okay, so maybe first I introduce the project. So the project is called the Sphere Project, and it's a project that deals with a lot of early modern printed books. So these are books that were printed between 1450, 1650. They were all circulated across Europe. So they were university books. They were taught to first, second year university students. And they all focused on astronomy. And essentially not just any astronomy, but geocentric astronomy. We know now that we are in a heliocentric system, but this all focused on geocentric astronomy, where the Earth is at the center and we're trying to see how the stars moved related to this kind of framework. And these books were also based on older treaties. So the printing started around 1450, but the treaties or the original treaties of these books were written around 1250. So we have a lot of these books, and we collected a lot of the metadata, and you can actually, I invite you to check the website. So this is the project website. The project is led by Matteo Valeriani, who is the historian and PI of the project. And from the project website, you can jump into the public database, which unfortunately doesn't contain the images, still have copyright issues, but contains a lot of the metadata that we're allowed to share and the connections between books. So it's still a very rich resource for someone who's looking to understand these books and how they interconnect with each other, how they spread across Europe. So we deal a lot with images, and you saw that my background is computer vision, so this is kind of something nice for me. But from this particular image, we have a lot of metadata that kind of filters into our knowledge graph. You can see already that we have original parts, so you can see that the box, the red box, this is the text that is printed in, let's say, 1500. But this is a copy of the original text that was written in 1250. So this is the original treatise. And what happened is that across time, there were people that commented on it. So someone saw the original treatise, which is not so big, and they wanted to make the book. They added comments. And this is the part in the green box. So these are all comments on this particular section. So we have a lot of various heterogeneous information in one page. Then we obviously have a lot of images in our book, and this image is very, very interesting because it tries to prove the sphericity of the surface of the Earth, right? So we want to see that the Earth is spherical in shape. And this reflects the content of this paragraph. And what you see here is a ship approaching land. And you see one person on the body of the ship, and another person here kind of occluded a little bit on the top of the mast. And the person on the top of the mast can see, as indicated by the line of sight, can see the shore earlier than the person on a lower altitude. So in a way, this was kind of you could think of it as a caricature drawing, trying to highlight the idea that the Earth is spherical in shape and there's a curvature. So we can see that images are highly correlated with the text content. So by studying the images, we can also understand the text. We also have a lot of these things, what we call decorated initials. So books at that time were structured differently, not always chapters, subheadings, and so on. So these nicely decorated letters served as a kind of a marker for the reader that this is an important place or a start of a new topic. And they had a lot of different decorations. I will touch on this very briefly towards the end of the presentation, but I just wanted to mention it here because it's an ongoing research aspect. And then we have marginalia. So these are, for example, indicating where the reader was interested. So maybe the reader was interested in some comment here. So we can see already that within this project, we have a lot of different things. This is even not touching the text itself, because all of our work now has not really touched upon the content of the text. Because the content of the text is very, very heterogeneous. Early modern Latin has a lot of abbreviation. There's a lot of regional wordings. So OCR results are always a bit messy. So we still didn't do that. We will try to do it in the next 3 years, but this is still not done. So all of these are stored in this sort of very schematic knowledge graph that I show here, but I will show later the bigger picture. So the idea is that the physical book, or the tangible book, if you want to say, is the center of the knowledge graph. And we have a lot of properties, a lot of information connected to each single book. And through these properties, the books are also interconnected. So if two books contain, for example, the same original part, because they reprinted, then you have this kind of semantic connection through the part. And you can understand how ideas were developed and shared across Europe in the early modern period. Okay, so the project started with around 350 books, and we started finding different corpora that are somehow adjacent to this Sacrobosco corpus, or the Sacrobosco treatise. So what we did is we started collecting them, and we built them basically in a knowledge graph that mirrors the initial one. So they are very highly interconnected. So we can start directly understanding the interconnection of all these books together. Which producers, so which printers, which publishers were publishing different topics, which parts or chapters figured in different books. So we have, this is a page from the original corpus we started with, and then we have the corpus of Pseudoproclus, which is heavy on Greek, for example. This is heavy on Latin. Then we have other two corpora, so one is called Feuerbach and one is called Gerardus, and these are also addressing different aspects of astronomical knowledge. Again, university textbooks, so very, very relevant to the original courses. So what I want to highlight here is that kind of knowledge graph, at least in our case, we had to make sure that all of these corpora are modeled in the same way, even though they have some slight differences. They had to be modeled in the same way so we can kind of leverage all this information that we have and connect them together. So now I can show you kind of how the general knowledge graph, this is kind of a snapshot of a simplified version of the knowledge graph. You can't read it. It's a little bit too complex, but I will explain it in a second. So the knowledge graph is made according to SciDoc-CRM deontology, as well as FRBR, as well as some cases, some our own vocabulary and our own kind of improvisations to make some shortcuts and make my life easier. And the knowledge graph, you can see here that is partitioned into multiple areas. So the book, the physical book, is at the center. So every single book of the 500 to 600 books is an entity. Then we have a green part here, which represents the semantic content of the book, the parts, the chapters. Sometimes you have parts that are adapted of other parts, so they're not really the same, but they've relied heavily on this. So this is all modeled here. Then we have information about the production, printers, producers, publishers, and authors. In the purple, we have information about copyright, modern and historic copyright. So a lot of these books had historic restrictions. So this is, for example, was granted to a certain publisher to publish this book. So we also record this. And the most interesting part is, from a physical aspect, is the blue part, which represents the content of each page. And at this stage, again, we don't have the text, but we have information about every single image in our corpus and every single page in our corpus. Yeah, so all this information, we didn't crowdsource it. This relied a lot on direct historical input. So we had some PhDs, postdocs across the years. This is a long-running project that didn't really read all the books. It's like almost 2,000, 100,000 to 2,000, 200,000 books, pages, sorry. So they didn't read it, and they're also in like 10 or 12 different languages. So you need to get really very specific PhDs to read them. So this, all the semantic information was kind of manually added to our platform. So we know that everything is supposed to be correct. So we use it as kind of a source of truth. So whenever we want to ask something, we add it there. So I mentioned before about conflict resolution. We don't have it because we have the historians who eventually go to the main source, to the primary sources, and find the truth, and when we add it. We haven't so far got like any case of conflict whether two people don't agree. So we use this as kind of a data storage and source of truth, as I said. And then from this, we derive historical analysis and computational analysis. And then we add it back to the knowledge graph. So that's why we call it like the ever-expanding knowledge graph, because it just keeps on getting bigger and bigger, and we keep trying to manage it and clean it and to ensure that our data is very coherent. But now the question is, our knowledge graph is becoming very big, and we are not able to look at every single chapter or every single part or every single aspect of that knowledge graph. But we want to look at the knowledge graph itself as a single kind of as an overarching view, and see what are the interesting patterns in the data. Are there outliers? Are there interesting phenomena, for example, that we can see? And come back to the historians to tell them, okay, I think these books are interesting. Maybe take a look there, tell me what you find, because I'm not the historian there, someone else knows it. So initially, we wanted to do something like just knowledge graph, well, entity embeddings using just regular walks, but we ran into the issue that a lot of times with SideOxCRM and FRBR kind of ontologies, things get too reified. So we have too many steps from the data we want and the data we want to obtain. So in this example, in our modeling, we have the physical book here, and the actual information about the part of that book. So if a book is made of 3 parts, they're kind of 3 hops away. And the idea here is to be very exhaustive with the ontology, is that this entity simply represents the content of the page that the publisher put, so including headings, including page number, and all the different things. And this entity here represents the actual treatise itself as the author wrote it, so the out of all the little additional stuff. So it's very nitty-gritty things that the historian wanted to add. So, but this makes a level of complexity computational. And eventually we get to the part here. So we wanted to kind of circumnavigate this and make something that allows us to make a reliable embedding of all the entities, so we can explore them in an embedding space where we can see what's similar to each other, what's not similar, are the different clusters. And that's why we came up with a method that is, we try to make it like a structured walk across the knowledge graph, but it adheres or tries to adjust itself to SideOxCRM properties or like knowledge graphs that are very reified. So the idea is very simple, actually. It's not so complex. So if we have a knowledge graph and we want to explore all the books of this knowledge graph, so we have 500 books. We start multiple structured walk according to our algorithm that start from that particular book. And every time as it walks across the knowledge graph, so if you consider here the book and we make a hop, we start collecting stuff as a sentence because CRM is made like, has very syntactical similarities with language. So what we end up doing at every walk, we create a sentence. And because there's some randomized element to it, we create multiple sentences per entity. So every book has now a document that represents it. And that document is a collection of the walks of the neighborhood of that particular book, going all the way to the leaf node, as well as jumping to other books. So essentially, once we end up having this document, we just generate an embedding using, at that case, we used Doc2Vec, which is just a text to vector model. Now we can use a lot of these bigger, nicer models to get maybe better embeddings. But in the end, we just need to use the n-dimensional entity vector. And this way we can project them all into kind of a single space, and then we can compare different things together and see what we find. Okay, and as a result, so we did this on our sphere corpus, and we were able to at least find some sort of interesting little phenomena that we had not seen before. So the coloring here is basically derived already from the ground truth data. So these are the different types of books. But we can already see that there are two main clusters. But the most interesting part that we found out is that there are two outlier clusters. And these two outlier clusters are like, okay, what are they? Why are they there? Why are they not like following the same distribution and other stuff? So the historians looked at it and they found out that these clusters are reprints, word by word almost, or like part by part of the same book, where they were produced at multiple years in the same city, same content. But what the producer did, and this is, for example, one of the publishers called Kaspar Poitze, and he just changed the cover page. So essentially, we had two different, like multiple entities of the same book. The same goes for the other cluster. So almost the same physical entity, but published as different edition. And they do that for economic reasons, because from other research within this project, we know that economic gain drove a lot of the publication cycle in the early modern period. Publishers were going bankrupt often, so they tried to save all the time. So if they had a longer print run, so they printed too much, they didn't sell it, they removed the first page, put another first page, add 2 years on it, call it a new book. So we were able to see some stuff like this. And just here is a little representation that we know that there's a randomness in our walks, but we wanted to just prove that the neighborhood of these embeddings is stable over time. So we had multiple runs, and you can see that for some entities, the 10 neighborhood is almost always the same. So their embedding is very close to all the other ones, doesn't change based on our randomness. On average, it's around 80% the same. So 8 out of 10 books are always in the same neighborhood. Some of the outliers here that change a lot are, these are some of the really rare books that we have. So we have maybe like 3 books in Portuguese, for example. They contain totally different stuff than everything else. So their neighborhood is always changing. Okay, so this kind of shows the part of the data exploration and how we tackle it from a meta level to try to see what's in the knowledge graph. And I can move on to the intangible part in a way. And if you consider, I mean, the definitions of intangible can be manifold, right? It's very difficult to say what's intangible. But in my definition, I would like to say intangibles are, in this case, the ideas that the producers of these books wanted to put in these books, but not by writing, but the thought process. So we have currently multiple projects. So the first one, I will discuss the last one, but the first one is already currently a PhD project by Noga Shlomi. So she's working on the visual representation of ideas. So how the visual representation, for example, of here, the sphericity of Earth, you see similar to the photo I showed before, but how the different visualizations change over time. And what does that mean from an art historian perspective? We have also another BA student, Annika Merklein, who's working on the styles of these initials. So she's working on trying to find the distribution of styles, not really comparison of the same stuff. So not really trying to find the same letters T, but trying to find the similar kind of vibe, if you want to call it, when it comes to these printing. So this is a style called arabesque, and this is the topic of, for example, her BA thesis. And she's trying to find all the different styles regardless of the letter and where they distribute across Europe, to try to see whether there were clusters of producers that were interested in the same style, or was there a trend at some point that favored one style over the other? Because these are interesting things. And this is highly not very well researched. It took forever to find people who can actually validate this thing. But what I want to talk about is this image here, where we try to use explanations to validate our model and get more insights. So speaking of the intangible, the question here is, how did early modern book producers think about visual elements? Or how did they think about these images they put in the book? What sort of unwritten ideas did they have in their minds that they wanted to project by making a drawing in a certain way? Did they want to project, I don't know, something or something else, regardless of what's in the photo? So to accomplish this, still have some time. So to accomplish this, I can show you at least some photos from the corpus. So we collected a data set of these images, and these images can be into different categories. So we have some images that we call mathematical instruments. And because these are astronomy books, we had a lot of mathematical instrument photos in them. So I forgot the scientific name for it, but you can see already here, this is the Earth, and there you have the orbit and the meridian. So these are instruments that you would find in an office, for example, or for a student who's trying to understand this. Then we have diagrams. So this is obviously not something that exists in the palm of your hand, and you see the scale is very different. And we have machines also that we supplemented our data. And these are more examples. So different instruments, different machines, that these are featured in our data. So what we wanted to do is not be able to classify them. So the idea here is to not just use AI to classify them. The historians know already. It's like 5,000 images. They did it manually. We know it already. The idea is to move from the linear paradigm of like collecting data, classifying it, get the results, because we already have it. But what we want to do is to add a loop. So we got the model. So this is the historians, so the domain experts. They collected the data, which is similar to this, right? So they collected them, annotated them, around 5,000 of them. And what we did is we trained the model, and that can predict the 4 different classes. So mathematical instrument, one class, machines, another class, diagrams, abstract diagrams, another class, and other. So we want a contrast class, so different stuff. So we trained it until it gave us good results, around 95% accuracy. That's best you can hope for. You don't even need more. But what we wanted to do is to see what the machine thought. Why did the machine, or the model in this case, think that this image is a mathematical instrument? And we see it through this heat map, which I'll explain in a second, and then give this explanation to our historians and say what information can they derive? Can they get more information about this image this way, like a different representation? So I already mentioned exactly how to do it. So we collected the data set, we trained the classifier, and then the explainable part here, we use a method called layer relevance propagation. Long story short, it tries to go from the output, so from the last neuron, to the input pixel of the image. So if a pixel has high contribution to the classification of a mathematical instrument, in our case, it's red. If it has negative contributions, like, okay, the model thinks because this blue patch exists, this is not a mathematical instrument, but because the red patches exist, this is a mathematical instrument. And in the end, the relevance was towards the mathematical instrument. So what can we do with this? That's the idea. So what can the historians do with it? Because the final arrow ends again with the loop of the domain expert. So we looked at it, and this is multiple snippets of the same image. And these are the results of the relevance for the different classes. So the model predicted this as a mathematical instrument, which is correct. So the image is a mathematical instrument. This is some meridian clock that was used at the time. with variable hours based on the position of the Earth. And we're trying to say what makes this instrument an instrument, and what makes all mathematical instruments in a way. So by looking at a lot of these things, we managed to realize that, okay, maybe what makes a mathematical instrument is the presence of a lot of graduated elements. So lots of these little lines and so on. The other thing is the bases are always highlighted. So what this means is that materiality in this case played a huge role to differentiate this from a diagram. Because a diagram, if you have a globe or you have any abstract shape, it doesn't exist in reality, right? So in this case, our hypothesis goes like that the printers wanted to emphasize that this has a base, even if it's irrelevant for the story of the meridian clock, because they want the reader to know that this actually could exist somewhere on someone's desk. So it's kind of grounded in reality. We have other cases. For example, this is an example of a machine. So this is some sort of grain mill machine. And you can see that the relevant elements are not really the wheels and the cogs, but the most relevant elements are stuff that indicate the scale of the machine. So the stairs, the windows, the walls around the machine. And this, again, was a very common theme across all our machine drawings. And we realized that, okay, the producers, again, of this image, our ongoing hypothesis, is that they wanted to highlight the scale of that machine for the reader. If you don't see it across, like in front of a wall that is clearly marked with brick lines, or tiles or windows, you will not appreciate or know how big this machine is. Then it suddenly kind of loses the scale to the reader. So we were trying to see like, okay, this is likely how they're trying to represent this. So suddenly the historians are not looking at it as a machine as, okay, what does it do? What are the cogs doing? And so on. But we're starting to look at different aspects that might be interesting. And I think for the last example, I can show you another one, some false cases, of course, because nothing is as nice as it is. So this is a scientific illustration. So this is, you can see it's a diagram. It doesn't exist. This is the sun orbiting the Earth. And these are days of the month and so on. But our model obviously predicted it as a mathematical instrument. And you can see the presence of a lot of graduated elements really kind of tricked the model. So it forces someone to rethink a little bit the definitions of things and kind of have some critical thinking into what goes into each class, and maybe refine the definition of these elements when creating a new data set in the next step. So that's where we were trying to go with this paper. So this paper is here. It's published recently, actually. And with this, yeah, I can show you a little bit just some ideas that we learned from XAI or explainable AI. We learned that scale, for example, mattered. Like in this photo, the bricks, while not so relevant for the machine itself, played a high part in identifying this as a machine. So it was really, we believe that probably the printers intended to put something that the reader can understand how big they are to signify the scale. The materiality, so we always have the basis of things and the basis around. It was also played a very determining factor in showing something that's physical, when, for example, in diagrams, it was also a little bit more abstract. So yeah, this would be kind of my conclusion for this. So the idea is that, in conclusion, essentially, is that our knowledge graph, which is our source of truth, that's kind of highly curated, and I would say we kind of duplicated 3 times to integrate all these data sets together. So knowledge graph kind of integrity is very important, at least in this project. So we can interlink different data sets together. But the main point that I wanted to highlight is I wanted to portray that we want to use AI not just in the humanities, at least, not as a tools to an end, but to start framing AI as a sort of a partner. Maybe historians will not love the word a partner, but maybe as like a assistant, you would say, that can help you see ideas a little bit differently than you would have seen it before. And with this, I just wanted to highlight that this is, of course, a very interdisciplinary team. So this is the PI of the project, Matteo, and then the rest of the scholars are contributors from different institutes. We work a lot with TU Berlin, as well as different other universities in the region. And yeah, with this, I would thank you all.
Thank you.